Hey YouTube, Zocchio here, and the fastest commercial airliner to have ever flown was of course the Concorde, although this plane was only made 14 times for passenger service because it wasn't able to fly over land at supersonic speeds. Although it could fly over the oceans at Mach 2.04 or around 2,179 kilometers an hour, it couldn't do this over land because of the sonic boom. But what is a sonic boom, and why does it happen, of course? Well, the speed of sound, of course, is 1,354 miles an hour at sea level, of course, or about 1,479 kilometers an hour. And when the objects, such as planes, are flying below this and are flying below a point called the transonic range, so basically if they're flying slower than Mach zero point 0.8, then the sound waves move around the aircraft, or anything honestly, because I'm technically moving when I'm making this video because my head's moving around, although it's very slow of course. And sound waves are able to get around me in a spherical shape before, I hit them because I'm going slower than them. However, once you start reaching the transonic range, these sound waves start to have a much harder time to get around the aircraft or anything else, of course, that's traveling at that speed, because the aircraft itself is moving so quickly relative to the sound waves. The speed of sound does actually decrease as you go higher up because it's dependent on the rigidity and density, and of course that will decrease as you go higher up in the atmosphere because pressure's lower and thus density. Anyway, point is, the object as it moves around 0.8 Mach to 1.2 Mach, in an area known as the transonic range, the drag will profoundly increase at a much steeper rate than it was beforehand. And this is faster than basically all airliners, which are in the range of around Mach 0.7 to 0.8, like the A380 or Boeing 747. And once you reach Mach 1, these sound waves are no longer able to get around the object because it's moving too quickly, it's colliding with them. And so it produces a cone shape behind the aircraft. They move out in a cone, almost like that, away from the aircraft itself, which is in front of the shock waves. And this, when it forms a cone, creates a really loud boom sound. And you may think that a sonic boom happens once, i.e. when the aircraft crosses the speed of sound, but no, it's happening along its whole flight path. So if Concorde were to fly over land as what was originally planned, then if you were to somehow catch up with it on the ground, you'd be hearing this really loud bang all the time. And of course, people on the plane didn't hear it though, because the shockwave, as I said, formed behind it.